All right, ladies and gentlemen, we're going to close up lesson 3.2, solving equations using algebra. And so we're going to take a look at solving these systems of equations using elimination. So we're going to do just that. We're going to eliminate a variable. So what we're going to do here is make sure that all like terms are lined up. So we're going to have x over x, y over y. If we need to, we'll have to do step 2. Sometimes we don't have to, but we're going to multiply an equation by a number to get its opposites. That means I'm going to have negative 2x and positive 2x, for example. That's what it means to have opposites. All right? Then we add the two equations together, divide to solve the new equation, and then it's going back to what we had before. Plug that answer into either of the equations, and then check your ordered pair. So let's go to a split screen, and let's see what that process is looking like. All right. So we want to solve the following system using elimination, also called linear combinations, because you're adding or you're combining the two equations together. So right now I want to see if we have like terms lined up. So we have x over x. We have y over y. So like terms are lined up. Now what I need to do is look for opposites. Well, obviously negative 3 and negative 5 aren't even close to being opposites. But if I look at 2y and 2y, those are close to being opposites. They're the same number. So what I'm going to have to do is what step 2 does. I'm going to have to multiply one of the equations to get opposites. So if I have 2y here, which is what we have, I need this to become a negative 2y. That's what gives me opposites. Well, because this is already positive 2y, this equation stays the same. So it's just negative 3x plus 2y equals, let me get that in there, equals negative 6. This, though, has to change. To go to here, I need to multiply by negative 1. So that's what I'm going to do with this entire equation, is I'm going to distribute negative 1. So this becomes a positive 5x. This is the negative 2y that we wanted. And this is a positive 18. All right? I'm going to erase that so I can combine those together. Step number 3 says to add these two new equations together. So negative 3 and 5 is 2x's. These cancel out, which is why it's called elimination. We actually eliminate one of our variables. And this equals 12. Divide by 2. And we get x is equal to 6. Now we're back to what we did before, and we have to substitute this into one of our equations. So I'm just going to go into this second equation here and substitute in for x. I get negative 5 times 6 plus 2y equals negative 18. Negative 30 plus 2y equals negative 18. Let's add 30. We have 2y is equal to, this is going to give me 12 for that. And then I divide by 2. I get y is equal to 6. Now we want to remember to write our answer as an ordered pair. So we have 6, comma, 6 for our ordered pair. And we need to check that solution. So I'm not quite sure what happened here. And I'm going to bring that back down so we can see what we have. So we're going to have negative 3 times 6 plus 2 times y, which is 6. And that's going to equal negative 6. When we look here, we get negative 18 plus 12. That does equal negative 6. We can type that into our calculator, so that looks like a good solution. If we check it in our second one, we're going to have negative 5 times 6. And then we have plus 2 times y. So we have plus 2 times 6. And that equals negative 18. So we'll check out and see what happens there. We get negative 30 plus 12. And we know that that does equal negative 18. So our answer's checked. So you can either pause the video, or you can move on to the next example. But I'd like you to take the handout. So this is the handout you got in class. And on that page 142 handout, do number 11. Do this on a separate sheet. because this is part of your homework assignment. All right, so let's take a look at our last example. We want to solve using elimination again. And so when we look here, once again, we don't have anything matching up, or we don't have any opposites of each other. And we also don't have any variable that has the same coefficient. And so what that means, when none of our coefficients match, I'm going to have to multiply both equations. So sometimes we do have to do that. And so I just decide, do I want my x's to match? Or do I want my y's to match? And it doesn't really matter. When I look at this, I decide to make my x's match. So that means 3 and 2 both go into 6. So I'm going to make one of them 6x. I have to make the other one negative 6x. So what do I have to multiply by? Well, I'd have to multiply this equation by 3. There's the 6x I wanted. 3 times 5y is 15y. And then 3 times 6 is 18. For my second equation, I'd have to multiply negative 3 by 2 to get negative 6. And so I distribute it all the way through. So 2 times negative 3x is negative 6x. 2 times negative 2y is negative 4y. And 2 times 2 is 4. Now I have the opposites that I want. And I get 11y is equal to 22. Divide by 11. And we get y is equal to 2. I'm going to go back and I'm going to plug it in for y. I usually go back to my original equation. The coefficients are usually a little bit smaller. It makes my mental math a little bit easier. So I have negative 3x minus 2 times 2 is equal to 2. We get negative 3x minus 4 equals 2. Add 4 to each side. We get negative 3x equals 6. And then when we divide by negative 3, we get x is equal to negative 2. So I'm looking at an ordered pair of negative 2, 2 for my solution. When I check that, I have 2 times negative 2 plus 5 times 2. And I want to know if that equals 6. So I have negative 4 plus 10. And negative 4 plus 10 does equal 6, so that's a good check. Type that in your calculator if you need to. I then have negative 3 times negative 2 minus 2 times 2, because you're plugging in for y. And that equals 2. We want to check that and see if that works. We have 6 minus 4, and 6 minus 4 does equal 2. So we've got some good answers there. The second on your own is on that handout again, page 142, number 15. And I need you to do that on a separate sheet, or I should say, the same sheet as number 11. All right, ladies and gentlemen, have a great evening.